evening, students. Today I am here with you to discuss the first chapter of class 12 physics, that is electrostatic. This electrostatic chapter consists of two units. The one is the electric charge and electric field, and the other is the electric potential and capacitance. Before going into details in the first chapter, first I would like to ask you a small question. Why it is electrostatic? Why it is not electrodynamics? Actually, this first chapter, electric charges and fields, deals with the static nature of the charge. Now I am going to answer you why it is called electrostatic. When two different bodies wrap with each other and there is a transfer of electrons from one body to other, as a result the body gets charged. Now here is a question. Electron will transfer from which body to which body? In this regard, there is a electrostatic series, and according to that series, the body which remains first in the series will lose electrons and will become a positive charge, and the other body that gains these electrons will be negatively charged. So charges are of two types, positive charge and negative charge. Now I am giving you the electrostatic series, which consists of many objects, but here I have taken 8 objects, which are number 1, far; number 2, glass; number 3, silk; number 4, human body; number 5, metal; number 6, ebonite; number 7, amber; and number 8, resin. So these are the 8 objects we have taken in the electrostatic series. According to the series, just now I have explained you, if you select any 2 objects from this series, the object that remains first in the series, when wrapped with another object, will lose electrons and will become a positively charged body. Suppose from this series I am giving you 2 objects. One is glass and the other one is silk cloth. When a glass rod is wrapped with a silk cloth, glass rod will lose electrons and will become positively charged body, and the silk cloth will gain that electrons and will become a negatively charged body. So this is the importance of the electrostatic series. Now here, look, I have divided the types of charge in 2 groups. One is positive other is negative. Negative charge will take place when in a body there are excess of electrons, whereas positive charge will take place when there are deficiency of electrons. Now we will take the characteristics of charge. Basically, charge, it has three characteristics. The first one is additive. So what is the additive characteristics of charge? If a system consists of many charges, this additive property states that the total charge of the system is simply the algebraic sum or algebraic addition of the charges. So this is the additive property of charge. And the second property of charge is conservation. For an isolated system, it states that the total charge is always conserved. And the very important property of charge is quantizations. Quantization of charge states that charge of a body is always some integral multiple of a smallest value of charge, and the smallest value of charge is the charge of electrons. So on the basis of quantizations of charge, if an object contains n number of electrons, and as we know that charge of each electrons is E, therefore the charge of the body will be represented by Q equals to Ne. This n is integer value which takes plus minus 1, plus minus 2 and so on. Now, here is an important question that we get in your NCERT exercise. The question is, if I say in an object there are 12 excess of electrons, so what do you mean? What is the nature of the charge? It's quite natural. Excess of electrons means the nature of the charge body is negative, and that charge we can find out from this formula. The value of n is 12. The charge of electrons is 1.6 into 10 to the power minus 19 coulomb. So from this formula we can find out the charge of the object, and quite natural it is a negatively charged body because of excess of electrons. Now, if it is asked, when a glass rod is rubbed with a silk cloth, the two bodies will get charge. The very important question is, when there is a transfer of charge, then is there any change in masses of the bodies? Answer is maybe very little, but yes, there is a change in mass. Why? So when some number of electrons are transferred from one object to other, maybe very small, but this electrons has mass, and the object that gains electrons, quite natural, if n number of electrons it gains, then its mass will increase by an amount n into m. So this is the increase of mass of that object which gains certain number of electrons, where m is mass of each electrons, and we know that the mass of each electron is 9.1 into 10 to the power minus 31 kg. So these are the three characteristics of charge. Once again I repeat, the first one is the additive nature, means for a system of charges the total charge is simply the addition of all the charges. Second one, the conservations. For an isolated system, total charge always remains conserved. And the very important characteristics is quantization of charge, means the charge of a body always some integral multiple of a smallest value of charge, which is the charge of electrons. So this is the first portion of electrostatics. Just now I have explained, so when two bodies react with each other, there is a transfer of electrons, and because of this transfer of electrons, the body gets charged. And this charge will not flow in the body. It will remain confined at a place. It cannot move. So that is why it is called electrostatic. As because of rubbing, the charge is created. That is why sometimes it is also called frictional electricity. So electrostatics or frictional electricity. Now, when some charge is given to a body, first you have to know how the charge will be distributed in that body. These distributions are of two types. Look at the chart. There are two types of distribution of charge. One is discrete and other is continuous. In most of the schools, it is a easiest example of discrete distribution of charges. We have seen in most of the schools, some guys are cutting their hair in such a way that some hair is here, some hair is here, some hair is here. So in that case, the distribution of that hair on the head is discrete. And if anyone wants to find how many hairs are there on the head, then he has to add all these hairs. So this type of distribution is called discrete. Whereas if the charge is distributed uniformly, and that distribution is called continuous distribution of charge. This continuous distribution of charge are of three types. When charge is given to a thin wire or uniform wire, then this distribution is in per unit length, and the charge per unit length is denoted by a term lambda. It is called linear charge density. As the unit of charge Q is coulomb and the length is in meter, therefore the unit of linear charge density is coulomb meter inverse. You know that the dimension of meter is L and the dimension of charge is current into time. So therefore the dimension of coulomb is T into A. As a whole, the dimension of linear charge density is L to the power minus 1 T into A. And the second kind of distributions is superficial or surface distributions. When charge is given to a seat, for an example, I am taking a seat of area A, and if Q amount of charge is distributed uniformly, then the charge per unit area of the seat will remain constant, and this term is called surface charge density. Sigma is equal to Q by A. In the same way, its unit will be Q is coulomb, area is meter square, so it is coulomb meter to the power minus 2, and its dimension is L to the power minus 2 for meter to the power minus 2, and dimension of coulomb is TA, so as a whole L to the power minus 2 TA. So this is the dimension of surface charge density. The third distributions, the third uniform distribution is cubical. When a charge is given to a three-dimensional body, and if the charge is distributed uniformly, then the charge per unit volume of the body will remain constant and is denoted by rho equal to Q by V, and its unit is coulomb meter to the power minus 3, and the dimension is L to the power minus 3 TA. So these are the three types of distribution of charge when it is distributed uniformly or in case of continuous distribution of charge. Next, the important thing is when a charge is kept in any place, around that charge there is a region where this charge will create a field. So why this field is created? What is the reason behind it? So what I have said, if a charge is kept in a space, around that charge in a particular region, the effect of charge will be there on another charge body or uncharged body. So this region is called electric field. Why in that region only electric field will be created? To know this one, we have to know another physical term, electric field lines or electric lines of forces. What it states? It states that the path of unit positive charge, it is imagined, or we can say this way, the imaginary path of a unit positive charge is called electric field lines or electric force. So this electric field lines has three characteristics. Number one, if the charge is positive, the electric field lines will be originated from that positive charge. If the field lines is if the charge is negative, the electric field lines or electric lines of forces will terminate into that charge. So this is the first characteristics of electric field lines. Its second characteristics is, if a positive charge is kept, so many electric field lines will be originated from that positive charge. So no two electric field lines will intersect. This is a question in board exam. The question is, why two electric field lines will never intersect? Now I am giving the answer of this question. Suppose two field lines intersected at these points. So as electric field lines is there, so quite natural there will be electric field. Now, as electric field is a vector quantity, if you want to find the electric field directions at that point, we have to draw two tangents on the two field lines. So if we draw a tangent at this point, if we draw a tangent at this point and these two field lines, these two tangents will give the two directions of electric field. But at a point, electric field has only one direction. So this is the reason why two field lines will never intersect. Once again, I am repeating the answer of this question. So suppose if two field lines intersects, at the point of intersection, two tangent can be drawn on the two field lines, which gives the two direction of electric field, which is absurd. So that is why two electric field lines will never intersect. Now the very important is the third characteristics. In any region, if two field lines is moving this way along a line, in that case, these two field lines will attract each other. So the characteristics is two field lines along the length will attract. But if in any space two field lines are moving in this way, so in that case the two field lines, if moves parallelly, so along their breadth they will repel each other. You know from the lower class that like charges repels each other and unlike charges attracts each other. Today we will come to know what is the reason behind it. So if it is asked why two similar charges repels each other and dissimilar charges attract each other, now you will be able to answer the questions. Here is the diagram. Here I have taken a positive charge, in front of that another positive charge. The first characteristic states that from positive charge electric field lines will be terminated. So from here electric field lines terminated, but that cannot enter into this positive charge. So here also electric field lines originated, here also electric field line originated, and they moves in a space in this way. And the third characteristic states that along their bed they will repel each other. As a result, two like charges repels each other. Now here, when negative charge is kept near positive charge, when unlike charges are kept nearby, then because of the first characteristics, electric field lines will be originated from positive charge and it can enter into the negative charge. And along their length, according to the third characteristics, they will attract each other. So that is why unlike charges attracts each other. I think it is clear to all of you. Next portion of this electrostatic is we have to find out some numerical questions here. The numerical question is, this is a very important numerical question. Question is, if a charge body carrying charge Q1 and another charge body carrying charge Q2 are kept in contact and separated, what will be the charges when they separated? The answer is, when two charge body are kept in contact and separated, the total charge after separations will be equally divided. So what is the total charge? The total charge is Q1 plus Q2. This is the total charge. When these two charge bodies are kept in contact and again separated, now this total charge Q1 plus Q2 will be equally divided when they separated. So now the charges in the body will be Q1 plus Q2 by 2, and here also Q1 plus Q2 by 2. Now I am giving you a short question of 2 marks. The question is, when a 4 coulomb charge and minus 2 coulomb charge are kept in contact, what will be the charges of the body when they separated? So 4 coulomb and minus 2 coulomb, what is the total charge? Because charge holds the additive nature. The total charge is 4 plus minus 2 equal to 2 coulomb. And when they kept in contact and separated, this 2 coulomb charge will be divided equally. So now charge after separation on each body will be 1 coulomb each. So this is the simple question. Once again I am repeating the question. When two charge body are kept in contact and separated, the question will be asked, what will be the charges of the body after separations? Next, I am going to explain you when two like charges kept nearby, then they will repel each other. Scientist Coulomb has given a law. What is the magnitude of this force? That is called Coulomb's law in electrostatics. Suppose it is a charge body of charge Q1, it is a charge body of charge Q2, and these two charge bodies are separated by a distance r. They are like charges. So force on this charge due to this charge will be in this direction because it is repulsive, and this force is F12. And similarly, the force on this charge due to this charge will be in this direction, and this one is F12, and it is F21. Why this type of notations? Because it is the force exerted by charge Q1 on charge Q2, and similarly it is the force exerted on charge Q1 due to Q2. Now according to Coulomb's law, F12 or F21, I am taking the magnitude part, is proportional to the product of the charges and inversely proportional to the square of the separation between the charges. Or we can simply write F equal to some constant into Q1 Q2 divided by R square. Now, the very important question is Coulomb's law and Newton's law, how interconnected? Before going into that, we have to know the two effect, one is induction and the other is conduction. First I'll explain you induction. What is law of induction? The law of induction states that when a charged body is kept near an uncharged body, this body is initially uncharged. When a charged body is kept near an uncharged body, the near end of the uncharged body will be oppositely charged. So this is the near end of the uncharged body. So here will be negative charge, opposite of positive, and here will be similarly charged. So this is the law of inductions. I repeat, when an uncharged body is kept near a charged body, the near end of the uncharged body will be oppositely charged and the far end will be similarly charged. So this is the law of inductions. Now just now I have explained you that between unlike charges there is attraction and between like charges there is repulsion. As the distance of attraction, attractive force is this one and the distance of repulsive force is this one. So the distance of attractive force is much less in compared to the distance of repulsive force. As the force is inversely proportional to the square of the distance, so quite natural, the attraction is more than the repulsion. So as a result, the overall effect is attractions. So what we'll see from outside? We'll see that when an uncharged body is kept near a charged body, the uncharged body will be attracted by the charged body. But what we can't see, that is the induction effect. So this explanation states that from outside we'll see the uncharged body will be attracted, but initially that will take place is the inductions. The question is, prove that induction precedes attractions. So this is the answer of this question. Why first induction will take place and after that uncharged body will be attracted by the charged body. Now, another questions. Suppose two body A and B, we don't know what are the nature of the charges of the body. So two body are kept nearby, and when attraction take places, so what you can say? If attraction take places between the two body A and B, so there are two answers. Answer number one, the bodies are unlike charges, and number two, one body is charged and another body is uncharged. Just now we have seen that an uncharged body is attracted by a charged body. So on the basis of attraction, there are two answers. Either the bodies are oppositely charged or one body charged and other is uncharged. But if the result is repulsion, we are sure to say that the nature of the charges of the bodies are like. So now you tell me, which one is the surer test to identify the nature of the charges of the body, attraction or repulsions? So this phenomenon states that by observing attractions, we are not sure to say what are the nature of the charges of the body. But if repulsion takes place, so we are sure that the bodies are equally charged. So that is why in board exam, most of the time giving the questions, it proved that repulsion is the surer test to identify the nature of the charge of the body. And the second effect is the conductions. Suppose this is the charged body and this is another body kept in contact with A. So when these two bodies are nearby or very close to each other, not in contact, then this rule is inductions. The uncharged body near end will be oppositely charged and the far end will be similarly charged. But when two bodies are kept in contact, then the whole body will be of similar charge. So if it is positively charged body, so this body will be also positively charged when it is kept in contact with other body. So this is the law of conduction. Finally, I will give you a numericals. The numerical is on the basis of this topic. The numerical is, suppose I have given you three objects, object A, object B and object C, and the charges of these objects are, this is Q, this is 2Q and this is minus Q. When this A and B are kept in contact and separated, and then B kept in contact with C and separated, what are the final charges? Look here, when A and B are kept in contact, after separation, the charges of the body, the total charge will be equally divided. Now the charge of the body, total charge is 3Q, charge of the body will be 3Q by 2 and the charge of the body of this one will be also 3Q by 2. So when A and B are kept in contact and separated. Now when B are kept in contact with C and separated, then what will be the charges? Now the total charge 3Q by 2 plus Q minus 3Q by 2 and minus Q. Now the total charge is 3Q by 2 minus Q is equal to Q by 2. And after separation, this Q by 2 will be equally divided. So the charge of body B will be Q by 4 and the charge of body C will be Q by 4. So what will be the charges of the body? 3Q by 2, Q by 4 and Q by 4. So today this much. If any common book you have, and from there you can practice this type of questions. Once again, I'll tell you to stay at home. Our next topics will be the second unit of electrostatics, that is electric potentials and capacitance. Till then, goodbye.